Gentlemen, welcome back to the shop. On this fine, frigid, even time, we retreat unceremoniously from the world of angry pixies and into the warm embrace of lukewarm, high-pressure mermaids. And I gotta say, I gotta get this off my chestles. I think I got unfairly branded a long-tailed pussy in a room full of rocking chairs on account of not wanting to blow myself up with the mere 12 volts of angry pixies what go in here. It's just the sparks. I don't mind the welding. I don't mind, when you flip a switch and you're expecting the sparks, that's no big deal. But who amongst us does not have a wrench, an open-end wrench, or a pair of side cutters what's got a big chunk taken out of it from shorting it out on a battery terminal? You just haven't lived until you've had a 4,000-pound forklift battery blow up on account of the welder welding beside it. Now, the other side of that, we can see hydraulic fluid, it's super dangerous when it's high pressure and it's squirting out, but as long as it's contained, ain't no big deal. And I think because it's easier to understand, there's no JFM, there's no just fucking magic going on here with hydraulics. That's why, we're going to have this A part, see how she chooches. It is a little Haldex pump. There we go. Haldex Hydraulics, Rockford, Illinois. We'll have a look and see how this works. She is a gooey, dirty lassie. You ever get the feeling something's not right, like your head's not in the game? All you can dream about is what you think about all days. Getting home and tearing off your wife's underwear. It seems like a clever idea at the first of shift, but after a couple hours of them riding up on you, fuck me. Oh, I know what's... I know. I took her off to give her a little hose down. There you go. Come on. Always those last little fucking Klingons. Just the barest will nots holding her all together. Come on. You stink too. Woo. Okay. This is a gear pump. We're in like sin, and surprisingly disappointing to me, this is not a single gear pump with a crescent, the kind what comes in an engine, infernal combustion engine to make the lubrication go. It's just one gear and then a crescent, and it's a positive displacement pump as well. But this is actually a 2-gear, just a very simple gear pump. Nonetheless, we will have a look and see how she chooches. Casting a discerning eye now, you continental metrique types are going to want to look away because I'm going to tell you something you're not going to like. Hydraulic fittings. They are generally all inch standard. So here we have, even in equipment, what you buy straight from Europe, it's going to have a lot of these O-ring boss fittings. Now, ORB, this is inch standard fasteners, fine thread. And the way it seals is on the O-ring. Now that is no longer an O-ring. It looks like a triangle ring. It means it's been cooked and it's lost its elasticity. So if you can, you'd want to change that. On the other end, what we have here is a JIC, Joint International Committee. This is on a 37-degree taper. And again, this is inch standard fine thread. So if you ever need to touch up the threads on one of these, and you don't have that size of fine pitch tap, you can use a bolt and do the old cut routine with with a file, and then just to clean it up, not to cut new threads, mind, but just to clean it up. And the most important part is the seating face right in here for that O-ring to wedge in there and actually seal up that 3,000 psi of hydraulic pressure. Interesting construction here. This, if you look at it, it almost looks like it was water jet cut, but then you look real close and you can see the mill scale pattern here, even though there's these striations. So this indicates to me that this is a specially manufactured steel cross section that gets extruded hot, so hot rolled through these dies to this shape, and then at the factory all they would need to do is buck these off, face them, and not even touch this outside part here. There's an indication that this was CNC machined for a fixture, and then some jaw fixturing marks here. So However this was, it was indexed on this little pinhole here. And on the forward section, quite a bit more complicated geometry. Obviously cast. Is it cast steel or is it cast iron? Having a look at this, it looks to be cast steel. However, the only way to be sure is to take a little chip out of there. We'll do that momentarily, but I'll explain to you how this works here. So on this section, the input section, well, the back section, we have two ports, one big, one little. So we know that the big port is going to be the inlet because we don't want any restriction to flow on the inlet, because if there is restriction to flow on the inlet, the pressure drops too much and the fluid cavitates, it boils, it forms bubbles, and you can hear pump cavitating because there's all these little snaps. You know, when you crack your knuckle, there you go. When you crack your knuckle, that is the synovial fluid. Is it synovial fluid? I believe it's synovial fluid forming bubbles and then collapsing very quickly, and it damages, well, it apparently damages your joint there. But the same thing happens to pumps. What will happen is they will get a dull and sort of pitted appearance. Over time they'll get pitted, but they'll start to get a little bit dull on the leading edge here, and then that will slowly grow. And what that is when the bubble forms and then when it collapses, there's a huge pressure spike, and it actually takes a chunk of metal out. It takes a chunk of metal right out of there just by a bubble collapsing. Now when the fluid gets pushed in, and pedantry aside, we all say it gets sucked in. It actually gets pushed in because as these are turning, it creates a low pressure zone in here, and the tank pressure is higher, so it actually the fluid gets pushed into the inlet. Now what happens is, so this gallery is flooded and we're turning in this direction, which at first when you look at pumps is counterintuitive, because you would think that you would want to jam fluid in here and force it through. That's not the way this pump works at all. It actually goes along the periphery, fills up each of these gear teeth, and then forces it into the other side. So for each rotation, you get a very specific, the exact amount of fluid per rotation. That makes it a positive displacement pump, as opposed to a non-positive displacement pump like a water pump or a centrifugal pump or a trash pump, that kind of thing, where there's no forced volume going through. It's just an impeller spinning and imparting energy. This is actually pulsing a specific quantity of fluid into that side. And that is why you always need a relief valve on the outlet of these pumps, because if you deadhead the flow, this pump is going to pressurize until something blows up. So you need a relief valve so that once it reaches a certain pressure, the relief pops off and sends the extra flow back to tank. Now, the thing is that people don't realize is if your relief valve pops off and you're running it against the relief valve and you can hear it, this entire pump becomes a heater. And all the energy in the system is heat being dissipated by that relief valve. All of a sudden, all the sight glasses in your tank melt out, and a big huge fire. You don't realize what's happening. What happened was the thing overpressured and didn't turn off. So you can overpressure it and send it over relief for a finite amount of time. It's going to heat the fluid up, but once that fluid gets hot enough to auto-ignite, partner, you're in trouble. So constantly people are sending me emails asking me how to make a log splitter or a pump or this or that. You know, I found an old pump in such and such junk bin. What valving do I need? Very rarely do I reply to that, because there is more to it than meets the eye, and it's not just Lego pieces what go together and lo and behold you got yourself a log splitter. There's a little bit of finessing involved there, and I don't want anybody to hurt themselves, so I really don't tell them any more than, unless they sort of have an idea what's going on. But if there's an email saying, I have no clue about hydraulics, but I just found a pump, no way, don't touch it. Having said that, there's no real resource online for the very beginner in hydraulics. So I'm wondering if that would be something that you guys are interested in going over, just building simple hydraulic circuits and testing them and seeing how they work. It might be kind of fun, actually. If you're interested, please put your comment there down in the doobly-doo, and we might do like a 4-part mini-series on building something simple like a press or a log splitter or something. So fluid comes in here, goes around the periphery. Now, what happens? There's going to be bypass flow that gets into the back of these gears because there's a clearance there. Now, the thing is about oil, and the thicker it is, the better. It is self-sealing. So oil isn't just for lubrication. I've said this time and time again, you know, with magic snake oils and this, that, the other thing. You know, you put some magic snake oil in your internal combustion engine and it'll run forever without oil. That's not true, because oil has more functions than just lubricity. It also cools, it seals, it cleans, it prevents oxidation, whole myriad of other things that aren't being serviced when you just put in some magic molly coat bullshit. So anytime somebody tells you there's some magic snake oil, automatically it's complete bullshit, because if it wasn't bullshit, heavy industry would be using the living fuck out of it to save money. And let me tell you, nobody runs their 777 haul truck, Caterpillar haul truck, on molly lube snake oil. Just putting it out there. Now this will have a little tiny gasket. Just a little wee gasket on here, and that's some sort of plastic what's been totally cooked off. But amazingly, you see the thickness of that, and that is what is sealing up the different faces from 3,000 psi. I mean, it's incredibler still is steam engineering, where they'll seal things up metal to metal for steam. To prevent steam from getting out. I mean, those surfaces would have to be so lapped. And steam, you know, I fuck around with some high energy stuff, but steam is a different beast altogether. Dangerous, scares the living shit out of me. Recall when we did the 3-phase induction electricity motors, there was a panel there, a tab, what told you all the specifications. The problem with this, it's the same situation where there is a governing body, SAE in the States, DIN in Germany, and JIS in Japan. I think DIN and German standards are very close because they're both metric countries. This would be an SAE pump, and the problem with pumps, even though they're Lego parts, a lot of the times there's no nameplate on them, or they're wiped off by the time, you know, cooked off or whatever, by the time these things wear out. If you want to spec this pump, a replacement part, so forth, with a reasonable degree of certainty, we need the machinist approximeters. A little bit of schmoo on there. We done released it good. We need to measure a few things. One is the pilot size. Yeah. So that is 1.7 something. Write that down. And then count the splines. That's 9, so that's going to be a 9T, but anyway. And 600 thou, so that'll be an A, but we'll look all that up. Then we need the bolt circle diameter. 1.9 something. And it's 4 bolts, so that's good. One of the things I done fucked up on, you know, is because these gears need to go from the inlet to the outlet around the periphery. They need to turn either clockwise or counterclockwise. But the problem is, despite having my fancy stare at center punch, I didn't witness mark these to see the orientation of the shafts. Because if the shaft is in here, it's got to turn clockwise. If the shaft is in here, it's got to turn counterclockwise. So right off the hop, there is a way to figure that out, because we need the high pressure in behind the seal, the high pressure to go back to tank, so or back to the inlet, so that we don't overpressurize this. That's the other thing. We don't know the application, whether it's a motor, that is, it has to turn both directions. Now that affects that seal. Now we need a far more skookum seal, because that seal, instead of needing to hold back the case pressure here, or the tank pressure, the inlet pressure, it needs to hold back full 3000 psi. So totally different seal in place for a motor or a pump. So I done fucked up, but ever forward, we will spec this out as if, and luckily I don't need to use this for anything because I don't have the gasket anyway. We will spec this as if it is a small pump that we're needing. Now we need the thickness of the tooth, and we need the OD as well as the dedendum. So we need the addendum crest size as well as the dedendum, and you might be better off to measure that bore there, because as you see there, they're not diametrically opposed perfectly. They're off by a wee bit. So we'll measure that. More schmoo. We'll measure that, and then we'll kind of approximate with the approximeters the thickness of that dedendum, or the depth of that dedendum. After a wee bit of the old jazz hands routine on the gargler, and this is far easier than it used to be. It used to be you'd have to get catalog cuts and look through fucking big voluminous catalogs in order to find what you're looking for. I'm gonna digress here into a bit of industrial meta. So sort of the behind the scenes of what you should do, knowing now that you have this superpower, you can spec any pump. Okay. 1, Komatsu, Caterpillar, Ingersoll Rand, anybody that makes equipment doesn't make the pumps. They don't make their own parts. They buy their parts off the shelf, and that comes with a price tag attached. So if you can buy this pump for 150 bucks landed, it's going to cost you $1,000 from Caterpillar. They got to get their pound of flesh. All these equipment manufacturers, they're not in the equipment business. They are in the spare parts business. Service, you bring in that Caterpillar truck. The service tech makes no fucking money for the company. He is there to sell you parts. They make money on the parts. Now, do not be that guy what's always fucking reinventing the wheel. If there is a shiny part number on there, buy the fucking thing from Caterpillar. Don't give yourself the headache, because if you're sticking your neck out now and you reverse engineer, which is essentially, or you reverse source this and you get it in from your hydraulic pump supplier instead of Caterpillar, if it's wrong, you're the asshole. It's not Caterpillar that sent you the wrong part. It's you fucked up. So you just watch that. You only pull this trick out, when you're in a dire need. Like the boss is saying, holy fuck, I can't believe this pump is $3,000 hairs. You say, hey, you want me to, over my coffee break, you want me to get on the confuser there and have a look and see if I can't find the pump from an alternate source? Then it's his choice to buy it or not. It's not you sticking your neck out. So don't reinvent the wheel every time. Just pull it out as a, as a big surprise. You don't want to be the know-it-all. Nobody likes a know-it-all. So just keep this between you and I until you need it. Now we start off with the shaft. That was a 9T 600 thou, and that puts us in, where's the shaft? We started off with the shaft. That puts us in SAE code A for the shaft. So we circle that. All right, 9-tooth. Just check all that. Yeah, that's the cock for dolly. Now we look at the pump mounting dimensions. 2-bolt. It's not a 2-bolt. It's a 4-bolt. And we go boot circle diameter, which is 0.78. There we go. Look at that. The pilot dimension is that. And then we double check with the bolt circle S. 2.5. Close enough. That's the guy. So it's not even an SAE designation, it's USA 4F17. Sort of an oddball little pump. Now the hard part. Now that we know with reasonable certainty the footprint, and we haven't even coincided the dimensions of the inlet and outlet ports, which is another data point that allows us to confirm or negate our conclusion, we also need the cubic inches. We need the displacement of the pump. So how do we get that? Well, what we did was we measured the OD of the bore, or ID of the bore, and also the dedendum. So this, if you look at this thing's spinning the thing, and what we want is the displacement per revolution. So what we need to do is find out how many cubic inches that volume is. So how do we do that? We take the OD, well, pi r squared, so we find the radius of that, which is half of 1.15. Then we square it, and then we multiply it by pi. That gives us a number. Then we multiply it by the thickness, and that gives us a volume. Here's that volume for the OD. Then we subtract this inner dedendum. Do the same thing, pi r squared times the thickness, and we subtract that. We come up with a number, 184 cubic inches. Now, you'll note that half of that ring that we've just calculated, half of that ring is taken up by teeth. So that's unusable volume because the oil can't go in the teeth. However, so what you would need to do is half that. We would need to half that. However, you'll note there's 2 gears. So you multiply a half by 2 and you get 1. So you don't even need to worry about that. So here is the cubic inch displacement per revolution as calculated. Now we look at the data sheets and we try and find, so we have the specification of the footprint of the pump, the mounting flanges. It's a 4F17. You do the old San Francisco typist hunt and pecker, and you find, lo and behold, Haldex pops up for that nomenclature. And then we look here at the W600. Looks different, but that's fine. And we see displacement in inches per revolution, 1.83. Well within our tolerance here in the Empire of Dirt. So that is the Cockford Dolly, this 030. Now what we got to do is we have to build the part number. Or what you could do is call your Haldex supplier and tell them, listen, I need this pump. Sales guys are happy to get out of the shop, go in and take you for lunch or just fucking blab. That's what they do. That's their job. Just go and blab. So if you can, you put this in a box and you give him a basket case. Here, I need this pump. And if he's any fucking good at all, he'll get the pump for you. No hassles. And you didn't stick your neck out. You didn't stick your neck out, right? So that's, cover your ass, right? You don't want to, nobody ever got fired for buying cat part. So in the catalog cut, which is rapidly it's an obsoleted term now that we have PDFs. Here's the PDF hard copy printout. Mother Earth guy sheds a tear on account of the dead tree carcasses. Okay, so what we do here is we do the standard pump, and then if you have any questions as we're building this, you can refer to the diagrams to see what you actually have. So here we go. Your options, example, design code, we're looking for a WP06A1, which is a single pump, so not stacked up. And then we go the CO material, we'll go B, it'll be Buna N. We'll go displacement, it'll be 030, which is one, as we calculated, 3 centimeters cubed, 3 cubic centimeters, as well as 1.183 cubic inches. And on down the list, we build this up, we give this number to our supplier, and we save ourselves a whole bunch of money. Now, as I said, don't stick your neck out needlessly. You don't want to be that guy what's always reinventing the wheel. It's a pain in the ass. But if and you wanted to, and you didn't have a seal supplier or a pump supplier, you buy this online super easily. Just build up that number, put it in the gargler or surplus sales of, where is it, Nebraska. They're great for old pumps. They got all kinds of used old crap. I buy from them quite frequently on home projects. For customers, I mean, they're footing the bill. They're paying for the good stuff. That's just the way industry works. That's just a Buna N double lip seal, low pressure with the preload supplied by a little spring of a thing back there. And we can see all this porting on the backside is to prevent this from pressurizing. So all these ports go back, get ported back into the inlet. That's how that works. So we never pressurize the backside of the seals or the backside of these shafts here because we'll blow that seal out. It's not designed for high pressure. So we need to mitigate that pressure buildup by putting it back into the inlet side. Now we got our A part. We can see if it's worth rebuilding. Generally, at $150 hairs, throw it right in the fuck it bucket. It's not worth even taking A part to see. However, it's interesting to see why. Of course, we are why guys. Why is it not worth rebuilding? And there's the, yeah, on the pressure side, we see some smearing. And this, of course, is steel. So a lot of times these are aluminum and they sort of wear in. But this kind of failure here, well, it's not really, it's just wear. And it appears to have something to do, it looks like some cavitation, but it's on the wrong side for that. It's on the outlet side. The cavitation would normally occur on the inlet side. But then as we're starting to pressure up, yeah, it's just the way it goes. But you see that finish there, horrific. So what would happen here is when the oil, when you first start up and the oil is cold, she'd run like a hot damn, no problem at all. But as the viscosity of the oil decreased, it got thinner and thinner, it wouldn't seal as well, and you'd start to have performance issues. so this there ain't no Viagra for this type of thing. And further to that, if you look at the gear teeth here, we can see a pattern on there. Yeah, on this guy here, you can see there's some cavitation where it's dull. Other than that, though, really nicely machined parts, and even lapped, of course, on this face, and that's critical in order to ensure that it seals up proper. Now this guy, it's been sitting for a while. We can see the marks. You can see the marks where the gear teeth have sat in here, corroded in one area and nice and shiny in another. It's just starting to get that black kind of corrosion on there. So yeah, this pump, completely garbage. No sense in putting her back together. Confirming now with the wee shaft that we got our money's worth out of this pump. On the sealing face, it's polished right up. A little bit of a divot on that first one. I even feel it through the love glove here. And also on the bearing faces, there is a different, it's starting to wear a little bit. You can see there's some patterning on there. So definitely got every plug nickel out of this pump. A qualification to that, a caveat, if you will, that I'm talking about for an industrial setting, in a piece of machinery or whatever, this is garbage. However, this would still run your log splitter, no problem. Just you'd put in some nice thick oil and yeah, she'd pressurize and no problem at all. I'm talking about if you're doing this for pay, yeah, throw it the fuck out. Garbage. Well, I hope you got something out of this trip down memory lane. Boobies. Ding, ding. I nearly forgot. We got to see if this is cast steel. Oh. There we go. Haha. That is cast iron. How can you tell? Because the chips are nice and gray. And the chips being gray indicate to me that there's nodular carbon in the matrix. So this is cool because it doesn't actually, it machines really well because it doesn't need any lubrication. It's self-lubricating. It's right full of carbon nodules. I will check this as well. Come on. Yeah, same. Look at the chips. Super gray, almost black looking. That's from the carbon being in there. Those nodules of carbon. There you have it. Oh, time to go. Thanks for watching. Keep your little Richard in a bad habit.